What is the relationship between quantum superposition and quantum entanglement? Quantum mechanics is a complex field that has fascinated scientists for decades. One of the most intriguing aspects of quantum mechanics is the concept of superposition, where a particle can exist in multiple states at the same time. Another fascinating concept is entanglement, where two particles can be connected in such a way that the state of one particle affects the state of the other, regardless of the distance between them. In this article, we will explore the relationship between quantum superposition and entanglement, their implications on quantum mechanics, and their potential applications in technology. Understanding quantum superposition. Defining quantum superposition. Quantum superposition is a fundamental principle of quantum mechanics that allows a particle to exist in multiple states or locations simultaneously. In simpler terms, it means that a quantum particle can be in two or more places at once. Examples of quantum superposition. An example of quantum superposition is the double-slit experiment where a single electron is shot at a screen with two slits. The electron is observed to pass through both slits simultaneously, creating an interference pattern on the screen. This experiment demonstrates that particles can exist in multiple states at the same time. Another example of quantum superposition is the Schrödinger's cat thought experiment, where a cat is placed in a box with a radioactive substance that has a 50-50 chance of killing the cat. According to quantum theory, until the box is opened and the cat is observed, it is both dead and alive at the same time. The role of observation in quantum superposition. The act of observing a quantum particle forces it to collapse into a single state, determining which one of the multiple possible states will be realized. This is known as wave function collapse and is a crucial aspect of quantum mechanics. The observer effect is the phenomenon that the act of measuring a particle's state will influence and change its state. This means that the act of observation can impact the outcome of an experiment, making quantum mechanics a challenging field to understand and predict. Introduction to quantum entanglement. Defining quantum entanglement. Quantum entanglement is a phenomenon that occurs when two or more particles interact and become correlated, meaning that the state of one particle is dependent on the state of the other, even when separated by great distances. A brief history of quantum entanglement. Albert Einstein, Boris Podolsky, and Nathan Rosen first proposed the concept of entanglement in 1935 in their famous EPR, Einstein-Podolsky-Rosen, paper. It wasn't until the 1960s that physicists John Bell and others proposed a testable experiment that could confirm the existence of entanglement. In the 1980s and 1990s, experiments confirmed that particles could become entangled, and that entanglement was a real phenomenon. Types of quantum entanglement. There are two types of entanglement: spin entanglement and polarization entanglement. Spin entanglement is based on the spin of particles, while polarization entanglement is based on the polarization of photons. The connection between quantum superposition and entanglement. How quantum superposition leads to entanglement. Quantum entanglement is a consequence of quantum superposition. When two or more particles interact, they can become entangled, meaning that their wave functions become linked, and the state of one particle depends on the state of the other. Understanding the correlation between entangled particles. Entangled particles are highly correlated, meaning that if one particle is measured, the other's state becomes known instantly, regardless of the distance between them. This phenomenon is known as non-locality, and it is one of the most striking features of entanglement and quantum mechanics. The implications of entanglement on quantum mechanics. Entanglement has significant implications for our understanding of quantum mechanics. It challenges our classical notions of reality and suggests that particles can be connected in ways we never imagined. It also has practical applications in quantum communication, computing, and cryptography. Implications of quantum superposition and entanglement. Quantum computing and communication. Quantum computing and communication rely on the principles of quantum superposition and entanglement. Quantum computers use qubits, which can exist in multiple states simultaneously, enabling them to perform computations much faster than classical computers. Quantum communication uses entangled particles to transmit information securely over long distances. Quantum teleportation. Quantum teleportation is a technique that uses entangled particles to transfer the state of one particle to another particle, even if they are separated by large distances. While it is not possible to teleport matter, it is possible to teleport the quantum state of a particle, which has implications for quantum computing and communication. Proposed applications of quantum superposition and entanglement. Scientists are currently exploring the potential applications of quantum superposition and entanglement in various fields. These applications include quantum sensors, quantum cryptography, and quantum-enhanced machine learning. As we continue to uncover the mysteries of quantum mechanics, the possibilities for these technologies are endless. Applications of quantum superposition and entanglement in technology. Quantum mechanics is a field of study that has been around for almost a century, and it has led to some of the most amazing discoveries ever made. The principles of quantum mechanics have been applied to technology, leading to the development of some of the most advanced electronic devices. Here are some of the ways that quantum superposition and entanglement are being used in technology. Current and future applications of quantum computing technology. Quantum computing is a field that has been gaining a lot of attention lately, and for good reason. Unlike classical computers, which use bits that can either be on or off, quantum computers use qubits that can be in multiple states at once. This means that quantum computers can perform certain calculations much faster than classical computers. Some potential applications of quantum computing include drug discovery, climate modeling, and cryptography. Currently, quantum computers are still in their infancy and are not yet capable of performing more complex tasks. However, researchers are actively working on developing more powerful quantum computers, and it is only a matter of time before they become a commercial reality. Advancements in quantum communication and cryptography. Quantum entanglement is a phenomenon in which two particles become connected in such a way that the state of one particle is dependent on the state of the other particle, regardless of the distance between them. This property of entanglement has been used to develop some of the most advanced forms of communication and cryptography. For example, quantum key distribution, QKD, is a method of secure communication that relies on quantum entanglement. In QKD, two parties share a pair of entangled particles, and by measuring the properties of the particles, they can create a secret key that can be used to encrypt and decrypt messages. Since any attempt to intercept the key would disturb the particles, QKD is considered to be completely secure. The role of quantum superposition and entanglement in advancing other fields. Beyond quantum computing and communication, quantum superposition and entanglement are being used to advance other fields as well. For example, in the field of quantum metrology, the principles of quantum mechanics are being used to create more accurate measurement devices. This has the potential to revolutionize industries such as healthcare, where more accurate measurements can lead to better diagnoses and treatments. Additionally, quantum mechanics is being applied to the development of new materials with unique properties. For example, researchers are using quantum mechanics to design materials that can conduct electricity without resistance at room temperature, which could lead to more efficient electronics and energy storage devices. In conclusion, the relationship between quantum superposition and entanglement is complex, but their applications in technology are far-reaching and exciting. While we are still in the early stages of understanding these phenomena, the potential benefits are vast and could lead to significant advances in fields ranging from computing to medicine. The relationship between quantum superposition and entanglement is a fundamental aspect of quantum mechanics that has far-reaching implications on our understanding of the universe. As we continue to explore and understand these concepts, we are likely to see even more groundbreaking applications in fields such as computing, communication, and cryptography. The study of quantum mechanics is an ongoing endeavor, and we can expect even more exciting discoveries in the future. Thanks for watching.